We'll begin by describing the values of the digits in the numbers 7, 70, and 77. This whole standard is really about reinforcing the idea of the values of digits in different places. So we're going to do this two ways. One is using counting, just counting and recognizing how place values were developed, just to remind students. And then we'll look at a model of multiples of 7 to connect to the ideas of multiplication. Let's take the number 7, for example. When we create the number 7, one way to do it is to just mark off 7 ticks. And we use for these 7 ticks the symbol 7. That's easy enough. But what happens when we go to the number 70? Let's continue counting. We start with 1, and when we get to 9, we start to realize that, wow, if we're going to just give new symbols for every single value here, it's going to get untenable. We're not really going to be able to do that. And so we come up with a shortcut and a more abstract notation, and we'll call this group of 10 ones, we'll represent it by a new digit in a new place. We take those 10 ones and represent them as one unit in a tens column. So this group this group of 10 ones is represented as a single tick in the tens column. And now if we keep going and count another 10, we will do this again and take these 10 individual units, and instead of continuing in the ones column, we'll move those over as one group of 10 in the tens column and nothing in the ones column. We've replaced the 10 ones with a single 10. And now we can keep going with this. Here's another 10. We'll make that 3 tens, or 30, 3 tens and no ones. And we can keep going all the way up to 70. So this is our representation of 70. We have 7 units in the tens column and 0 units in the ones column. And what we're trying to get the students to see is that the digit here is worth 10 times what it would be over here. This 7 here is really a 70, really represents 70, where this 7 here represents 7 ones. So let's now look at 77. We're just going to take the 70 and add another 7. And so now we have the number 77 with 2 digits, where the left-hand digit is worth 10 times as much as the digit to its right. Let's look at this again now from the point of view of multiples of 7. Here's a representation of 7 items times 1. When we double that, we have 14 items, or 2 times 7. And we can continue to 3 times 7 is 21 items, and continue on up to where we get to 9 times 7, which is 63. And when we get to 10 times 7, you'll notice that in the abstract symbolic representation of this many units, the digit 7 reappears here in the tens place now, as we talked about before, with a 0 in the ones place. So we can look at this as 10 groups of 7, and when we have 10 groups of 7, the symbolic representation really just moves this digit one digit over to the left, one place over to the left, and we get the number 70. But there's another way to look at this, and that is that we have now groups of 10. So these columns each represent a group of 10. And so we can think of this rather than as 10 groups of 7, we can think of it as 7 groups of 10, which is in fact this 7 in the tens place, are the 7 groups of 10. And this pattern will of course repeat regardless of whether we're starting with 7 and up to 70, or 5 to 50, or 6 to 60, or any particular digit. So when we take 7 and compare it to 70, what we've really done is taken this